Hello everyone. In this video we are going to solve the problem number 1.38 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. A point moves with a deceleration along the circle of the radius r so that at any moment of time its tangential and normal accelerations are equal in moduli. At the initial moment t is equal to 0, the velocity of the point equals v0, and it is asking to find the velocity of the point as a function of time and as a function of distance covered s, and the total acceleration of the point as a function of velocity and the distance covered. So this particular figure is not related to this problem. So let us first draw the circle. So this is the circle. Let us say the radius of this circle is r. Now initially at the time moment of t is equal to 0, the point was located at this particular point on the circle, and it is having the initial velocity of v0, let us say in this particular direction. Okay. Now at the moment of t, let us say the point is at this particular location on the circle. So and at this particular time instant, let us say this is the tangent to this circle, and let us say this is the direction of the velocity. So in the direction of velocity we are having the tangential acceleration, and the direction towards the center of the circle is the direction of the normal acceleration. Okay, so in the problem it is given that at any moment of time its tangential and normal accelerations are equal. Okay, so let us say at time moment of t, magnitude of the tangential acceleration is equal to magnitude of normal acceleration. Now as in the problem it is saying that the point is moving with deceleration. Okay, what does that mean? The meaning is that the velocity is decreasing. Okay, so we can write the tangential acceleration is equal to minus dv upon dt. Why I have written minus here? Because here at is positive, because we are talking about the modulus, and dv by dt is negative because the velocity is keep on decreasing with time. So that's why we have put negative in order to make the entire quantity positive. Okay, so we will substitute the value of at in this particular expression, and we can write minus dv upon dt is equal to, and the normal acceleration we can write it as v square by r. So we can say this particular equation is our governing differential equations. Okay, now from this particular equation we will find everything whatever asked in this problem. Okay, so let us first talk about the first part. In the first part it is asking to find the velocity of the point as a function of time. So we can see here that this derivative is done with respect to time, so better we can use this particular expression to find the velocity as a function of time. For that, let us take v square to this particular side and dt to other side. So we will get minus dv upon v square is equal to dt upon r. Let us integrate both the side from t is equal to 0 to t, and at the time instant of 0 we are having the velocity of v0, and at the time moment of t let us say the velocity is v. So we can write it here 1 upon v0 into v is equal to integration of 1 is t from t is equal to 0 to t. So basically dv upon v square integral, we can write it as v to the power minus 2 dv integral. So we can do v to the power minus 2 plus 1 divided by minus 2 plus 1. So we will get minus 1 upon v. Okay. So from here we will get 1 upon v minus 1 upon v naught is equal to t upon r. Okay. So from here we will get 1 upon v is equal to 1 upon v naught plus t upon r. So the value of v, which is the function of time, we can write it as v naught r whole divided by r plus v naught t. Okay. So this is the expression we got, that is the expression of velocity as a function of time. Now let us talk about velocity as a function of distance. Okay. So for that we can write dv by dt is equal to v dv upon ds. So we will use this particular differential instead of this particular differential, because here we are having the expression in terms of ds. Okay. So let us substitute the value of dv upon dt, and we can write minus v dv upon ds is equal to what is in the right hand side, that is v square by r. v square by r. So from here we will get minus v dv whole divided by v square is equal to ds upon r. So from here we can write minus dv upon v is equal to ds upon r. Let us integrate both the sides from s is equal to 0 to, let us say, s is equal to s, and initial position is at v is equal to v naught, and the final velocity, let us say, v. Okay. So the integration of 1 upon v into dv is given as ln v. So from here we will get minus ln v is equal to s upon r. Okay. From v naught to v, so we will get ln v minus ln v naught is equal to minus s upon r. Okay. So from here we can write ln v upon v naught is equal to minus s upon r, because ln a minus ln b is ln a by b. So from here we can write v is equal to v naught e to the power minus r in r. Okay. So this is the expression of velocity we got as a function of distance. So velocity as a function of distance. Okay. Now let us come to the second part of the problem. In the second part, it is asking to find the total acceleration of the point as a function of velocity and distance covered. Okay. So we know that in the B part, we know that the modulus of tangential acceleration is equal to normal acceleration. Okay. So from here we can write the normal acceleration is equal to v square by r, and the total acceleration we can write it as, let us denote it by a total, is equal to at square plus an square under root. Now first of all we have to find in terms of the velocity, so we can make use of this normal acceleration. So we can write at is equal to an, so we can write an square plus an square under root is equal to root 2 an. So from here we will get root 2 times an is equal to v square by r. So this is equal to a total. Okay. Now it is also asking to find in terms of in terms of distance covered. So for that, what we can do here, we can substitute the value of v. We can write a total is equal to root 2 by r into, and we will substitute the value of v from this particular equation. So we can write v naught times e to the power minus s upon r whole square. So from here we will get root 2 divided by r times v naught square e to the power minus 2s by r. Okay, so root 2 v naught square whole divided by r e to the power minus 2s by r. So this is the expression of a total we got in terms of only this distance, because both r and v naught is constant. Okay, I hope the entire procedure is clear. Thank you.